Hello, LinkedIn, Twitter, Twitch, Facebook, and of course, the ever wonderful algorithm driven YouTube. My name is Frank Lavinia, and today, doing something a little different, a little experimental. But you can catch me on the following URLs: Frank Diggs Data, franksworld.com, datadriven.tv, and impactquantum.com. You can also catch my YouTube channel at franksworld.tv. Yes, it does redirect you. All right, so I'm doing something a little bit different today. And today I am sharing with you all a webinar that was done that previously you had to register to do it, but it was a webinar that took place on Wednesday. And this has been a long week, so it's hard to know what's happening. But today is a little segment I like to call Fedora Fridays. And with that, let's cue the graphics. All right, with that synthwave music and intro, I put on the red hat for Fedora Fridays. Remember, it's about the hat, not the OS. And I talked to you about all the cool things we're doing here at Red Hat in regards to data services. And to that end, this week, I am sharing a webinar that I co-led with my colleague Guillaume. And it was basically about the context for this was that you would have, this was meant for partners who do consulting and work with the educational market, but basically the focus is on education and our success that we've had with RHODS, or Red Hat OpenShift Data Science, in academic communities. So to that end, I will queue up the video and I will be watching live. Even though it's recording, I will be watching live and I'll be answering your questions in the chat, and or maybe do it later. So let me kick off the video. It's the first time I'm doing it, so let's give it a shot.
All right, well, welcome everyone to this webinar focused for our partners on RHODS, Red Hat OpenShift for Data Science, our education focus solution. And have a good group, a good team that we've worked together to pull together these a deck and answer your questions at the end of the meeting. And I'll start with some introductions, and then we'll get into some poll questions. We're curious to know a little bit about the folks that are joining us here today. So on the meeting here today, so myself, I'm Craig Waykazer. I am a channel development exec in our advanced build program. Shout out to those partners from the advanced build program today. Thank you for joining. Guillaume Motier is a senior product marketing manager with Red Hat. He's going to be sharing the demo today. Will McGrath, product marketing manager, I think also a senior with Red Hat on the RHODS side. We look to him for a lot of open questions and driving the product in the background. And Frank Levin, our cloud services leader, and he's going to handle the bulk of the presentation here today. All right, so I like to throw in a key takeaways slide. So if you have to run, if your manager or better half, grabs you 5 minutes from now, here's the takeaways, the key takeaways for today. So clearly, education clients love open source, and they put not only they like to use it internally, but share it with their students for teaching and training. And so this is a great solution with this open source framework. However, education clients don't like being software integrators. They're not software houses. And so, and more are using these education compute, learning platforms with Jupyter notebooks and other things. but it's not easy, right? There's no help desk for open source if things don't work. Integration, things change. So oftentimes they end up, being IT, which they don't want to be. So RHODS is a great cloud-based services option for them. By the way, there will be an on-prem version in the next release, but initially it is cloud services, and we fully expect most of the universities and educational companies to do cloud, but there is that option that's coming down the road. So an overview, it incorporates more than 30 of the common open source technologies. I've listed a few of them there: Python, R, TensorFlow, PyTorch, Jupyter, and integrated together, hardened, like Red Hat does with Linux and other solutions like OpenShift and Ansible automation platform. So we do all the heavy lifting to make it work. And so, as I put in the upper right, to hit the easy button for your education clients. We need partners like yourselves to be able to work with these education clients and take this to them. And then as a partner, for you, really, it's another avenue for you to engage with your clients and improving your mind share with them. Quick agenda. So I've handled introductions. Frank Levin is next. He's going to be handling the education opportunity and the value proposition. We're going to talk about a great case study, success story at Boston University. And then Guillaume will have a quick demo. And then we'll talk about next steps, call to action, and then a Q&A at the end. So with that, let's go ahead and take it over to Frank. Frank, if you want to go ahead and share your screen. And Frank, you're on mute.
Meeting until somebody does the mute button down. So one of the things we've kind of noticed as the education community gets more and more involved in technology, you're starting to see a number of patterns. One of them is my personal favorite: the laptop ate my homework excuse to get deadline extensions. But also there's this idea that the technologists inside the universities and educational institutions have to do more with less each year. And ultimately what this means is that office hours, instead of being used for what they originally were intended, start becoming about tech support hours, right? And you also have the students that are getting up very very anxious about will their computer work? So one undergrad student, he decided to install PyTorch on every computer in the house, which I'm sure his roommates must have really enjoyed. But also there's this need for teaching this linear regression with more than just Excel. And I also do appreciate the call out to the IT crowd on the lower left. So what are the pain points for educational institutions? Well, there are a number of them. I won't read them all, but ultimately you have a high variability of needs across faculty, teachers, and students. There's also high peaks of activity during classes and just before deadlines. There's a high variability, I would point this out, student-owned devices. And ultimately, that leads to situations where someone can have the fastest laptop on the block and someone's using a hand-me-down from a relative. So you have a very wide degree of compute resources. And some software has different or contradicting software requirements. They may clash with one another. And also, this is a low value activity, right? The troubleshooting, installing this. And then finally, this is really where I think it really nails home for the educational institutions, is this has to be repeated every semester, because every semester you get a new crop of students. So this is not just fix once and move on. This is address this every semester with a complete new crop of students, with new challenges, new laptops, new devices. And ultimately, the subjects being taught in this space are rapidly evolving. Data science was generally not taught 10 years ago. There were very few institutions that had a data science program. MLOps is not taught yet. What does the future hold? When you kind of look at it with that, how are budgets and resources and skills going to be able to maintain and grow in a situation that is very fluid when they're already struggling to keep afloat now? So what is the education here, right? What's in it for me, for the partners, right? Well, obviously, there's a significant growth in data and analytics interest and programs that are being spun up all across the country. There's also, sciences, right? This is not strictly a data science or data analytics story, right? Any science that uses mathematics, which is, spoiler alert, all of them, from the social sciences to the hard science, they require some kind of mathematical compute surface. That definitely helps. And that leads into the next aspect here, open courseware. The idea that you can use Jupyter notebooks or some kind of way to integrate text, images, and compute assignments and code all within the same window with all that is all of this. It's repeatable, right? So once you want something that's repeatable so you can stand it up and not have to deal with it all the time. And RHODS is based on open source technology that, all of these technologies are all based on Jupyter notebooks and Jupyter Lab and Python, and all of this innovation that's happening in the data space is largely open source. And finally, the opportunity here to level the playing field so that the smallest educational institutions have access to the same compute that the largest researchers have. It's the idea that we can have everybody kind of working or access to the same type of compute. So what can Red Hat OpenShift Data Science do for your business? Well, as a partner in the education space, you are helping your customers solve a very real pressing problem. And you can also, again, I mentioned this, but level the playing field across institutions, whether they're large, whether they're small, or somewhere in between. They don't have to drop millions upon millions of dollars on a data center. This allows you, as the partner, to land and expand. You can add net new business by offering this to your educational customers and grow your connections within those organizations. So not just kind of central IT, but also kind of faculty and department IT. And this lets you build trust because you're leveraging the open source technology that's already out there, nothing proprietary, and Red Hat's expertise in running a cloud service. So Red Hat OpenShift Data Science, or we call it RHODS. So if you hear me say RHODS, I'm not referring to the things you drive on, although I will say that where we're going, we will need roads. So Red Hat OpenShift Data Science provides a computing environment for students, faculties, researchers, and everybody in between that's simple, managed, supported, and scalable. Well, what do I mean by simple? Well, it's easy to get started, and it's simple to maintain. There are low administrative costs. So your burden of spinning up a new service and the TCO of that, total cost of ownership, is going to be very low because it's all completely done through the browser and it's all done on our servers, and we manage all of that for you. Again, it's a managed service, so there's no additional infrastructure to deal with, not even virtual infrastructure. So we manage the patches and security updates for you. This is a fully managed service. This is a platform as a service offering, and you don't have to do anything in that regard. It's supported, right? So it's fully supported. You get a full SLA, and this is backed by Red Hat SRE, some of the best people in the industry. So this is going to be reliable. It's also scalable. Scales up to meet demand, right? So just before the midterms or whatever, when every student is hitting it, there's not going to be any lag or anything like that because the clusters will grow to meet up for that. And more importantly, it will scale down to save on costs. You're not paying for compute you're not using. And again, this really allows smaller colleges and universities to benefit from advanced compute because they don't have to purchase this hardware, they don't have to care and feed for it, but they also don't pay for what they don't use. So if everybody's off for a holiday, for a week, spring break, nothing's on, you're not paid for it. All right, so what are the benefits of specifically of using Red Hat OpenShift Data Science? Well, for faculty and research, spend more time teaching, right? That's what you're doing. You're not there to debug laptops. That's not a value add activity. You can also create default notebook images. And we ship a number of default notebook images, which is basically what the industry uses for data science. And these do change and grow over time as the industry changes and grows. But you can also build your own custom notebook images, right? So if you have a statistics class, economics, psychology, you name it, and there are specific packages that you want to install and have students kind of up and running with already, you can do that. And you can access to technology partner software if you need it. It's consistent and fair and reliable for all students. And this doesn't have to be just for classes, right? This could be for research projects, publications, etc. Now for IT, it's a core, at its core, it's OpenShift, right? So it's supported by Red Hat, so all the maintenance, uptime, all of this is managed for you. As I mentioned, the environment can auto scale. It can go up to meet peak demand, and it falls back down. Well, that sounds bad, but it scales back down in order to reduce those costs. So you're not paying for what you don't use. And again, multiple environments can be built and destroyed quickly. And this is important because if you just want to spin up something for a research project or just a temporary idea, you want to spin it up, you can spin it up. It worked. Yeah, well, let's talk about what we're going to do with it. Or it didn't work, and you can just take it down, and there's no pomp and circumstance, if you will, to taking down and setting up and taking down the environment. You also reduce the need for shadow IT, which is basically the idea that data scientists will install dependencies into their models and not really mark and log that. You have the built-in notebook environments that can really kind of control that. Now, as for students, it's browser-based. There's no install. This will work on any device. This could work on an iPad, although I imagine you'd probably want a keyboard. But this could work on any device regardless of its what it's capable of doing, whether it has a GPU or not. The environment is available 24/7. And if it works on your device, it'll work on your teacher's device, your roommate's device. It'll work anywhere. And it's available during class and for assignments. Now, an interesting thing here, I kind of mentioned the idea of a quick takedown, build out and takedown. This was a hackathon for data science that was a challenge for students to create AI able to playing a game. And this was done at the University of Brussels. And this used RHODS as the AI platform. And basically, it was able to scale the environment up for the hackathon. And once the project was done, the hackathon was done, it was shut down. That was it. There was no processes in place. It was just very easy to kind of set up, have a hackathon, and then tear down when it was done. It really saved in terms of cost, in terms of effort, and in terms of time, right? There were no provisioning of machines, and everything was able to scale up and then scale down based on the needs of the individual project. Now, let's get into what our success has been at Boston University. This is a case study looking at kind of what was needed. All right, so ultimately, this was meant to be it's an implemented an interactive lecture and lab environment for computer scientists and engineers based on this technology. The usage peak was 300 users and 100 concurrent users during the spring semester. This integrates with what the Boston University online textbook material was. That was also built with this technology, Red Hat OpenShift Data Science. You're seeing a lot of this, that Jupyter Notebooks and Jupyter Lab are being used in this capacity because, well, again, it's a format that allows you to combine images, text, so you have lecture material as well as exercise material, and it's interactive. So one of the things that I want to point out here is that we had a fast time to solution. So this was basically deployed in December for classes that started in January. So this is a project that you could start now and pitch to your customers now, and it'll be ready for the fall semester. And I think that the speed of this, because it is a managed service, it's entirely in the cloud, I think cannot overstate that. And because of that, because of all of the advantages that you have with the platform as a service, it lowers the cost. Right? It scales based on demand. It enables bursts of activity, and it can handle lulls in activity by scaling down. All of these factors make a win-win for everybody. So what was the background of this Boston University project? So the objective was they wanted a general platform for the entire university to work with these open source textbooks, right? The notion of using Jupyter notebooks as a way to create courseware and course material, that's not a new idea. That's not unique to Boston. It's a growing movement that you can capitalize on with RHODS. And then the objective was, well, they don't want to have anyone to install anything. They don't want to have them to do anything. And they wanted to provide a web browser-based experience to introduce students to Linux computing. And your eyes do not deceive you. The actual case study here had nothing to do with data and analytics. This was teaching computer science, right? So don't think that this has to be a data science only story. Again, any subject matter or subject that can benefit from a compute surface and uses mathematics, which is a lot, can benefit from this. The customer pain point was basically that the laptop ate my homework, or office hours turning into tech support hours, right? It's really a way to offset the technical debt that students have to pay to get started with Linux, right? And students already have plenty of debt to deal with. We don't need to have technology kind of thrown onto the pile. So this is really a way for Boston University to get started pretty quickly. All right, so what are the features of OpenShift Data Science? Well, here's a couple. I mentioned this a couple times, but I think it's worth noting because a lot of organizations they hear the cloud, they hear about this, they're not really sure what exactly that means in practical terms. Well, in practical terms, when you have a spike in usage, probably the night before an assignment is due, we can have an architecture, that will scale up based on that. So what you're seeing here is real data from this last spring semester, where there was a spike in demand and there was a number of cores went up to meet that demand, right? And again, before a major deadline, you also see that go up. And you'll notice that the response in terms of the architecture scaling to meet the demand is proportional to what's actually happening. You can further control costs by managing storage quotas, right? Not every student is going to need 20 gigabytes or 20 terabytes, right? You can control how much storage is based for all users and per user. You can also stop idle notebooks, right? So very often in a lot of data science and a lot of heavy compute, you leave it run overnight. But if it stops at 4 in the morning, you don't necessarily need to have it running up until whenever you wake up to take a look on it. If it's idle for 2 hours, if it's idle for 1 hour, basically it can be anywhere from 10 minutes to 1,000 hours, and they basically are stopped at that point. So you have the ability to control that. Again, another interesting thing here is that these are the notebook images that we ship with, at least as of now. There's probably going to be a few more. I think Guillaume can talk about that. But basically, minimal Python, standard data science, all of these things that can be here, OpenVino, all of these things this is a rapidly evolving innovation is happening at an amazing pace. And this lets you kind of take advantage of the work we're doing to take these upstream products and projects and roll them into predefined images. Again, if nothing you see on the list fits your exact particular customer's needs, well, you can define your own. And this does help stop shadow dependencies because folks that are installing this or curriculum organizers, they can define exactly what they want installed and what they need, and they can have a custom image created just for that course. All right, so another thing that we've noticed is that we like to call this notebooks as a service, because I think that really kind of explains exactly what this is, and it removes a lot of the operational complexity and a lot of the startup friction and costs of barriers to entry to get into this space. And with that, after you see this animated GIF repeat a few times, I will turn over to my colleague Guillaume, who will do a demo.
Thank you, Frank. Yes, we're gonna see this running live. Just let me share my screen. It will be okay. So now just to quickly come back to what Frank showed in the slides, this is a RHODS environment. So this is exactly what you get when you subscribe to RHODS. This is a fully managed service. So of course you still have access to the underlying OpenShift and other standard thing. But normally, if you don't need this type of access, that's the UI that you get, and that's all the features and functions that Frank just showed. Just to quickly come back to two different aspects that were important for Boston University. First, again, the cluster settings. Normally, standard RHODS comes with 20 gigabytes per user. In the case of the university, they wanted, of course, to reduce this a lot because they didn't need this for the type of course that they were teaching. And also the idle notebooks was really important in their setup, just to make sure they don't consume too much resources if students just leave their things running. It's very easy to leave anything running because as you understand, as it's not running on your laptop, Chromebook, iPad, or whatever, you just close your device, but in fact, the notebook is still running. Another important aspect is this notebook, the custom notebook image that you can bring in, because for BU, as it was a course on computer science, they had very different packages and applications that they wanted built in inside their environment so that their students could directly play with those applications or those libraries and the rest. So in this case, this is a standard RHODS deployment. And let me show you quickly if I want to launch an application after I authenticate. I got here the different notebook images that I am able to launch. There are quite a lot on this cluster. This is our own internal cluster where I'm developing new custom images. So if your customers want to use a very specific image with very specific packages, again, and applications and the rest, this is easily done and integrated. You can see it doesn't even have to be a PyTorch, to be a Python notebook. A standard Python notebook can be with R Studio, other type of environments. It can be brought in. And of course, you can customize the different deployment size to which the different users have access to. Okay, so maybe in a case of a specific course, you want to restrict, there is only one configuration that is available, and that's it. It's the same for everyone. You simplify this. There is even a way to bypass this. So you could publish in the content of your course just a link that would directly select and launch the right image for you for your course. Okay. In my case, just to show you how this works, I would select a standard data science notebook. It will be scheduled on the cluster, and it will take a few seconds to start. And of course, this is a live demo. It takes a little bit more time that would be normally the case. But at the end, I will have my environment, and most importantly, I will have my own environment. Even if the container itself is totally ephemeral, it's launched on demand and it consumes resources on demand, all my files, all my things will be directly reconnected inside the environment. So as you can see, this is my personal environment where I have tons of demos, experimentations, and the rest. They are saved on the cluster and reconnected at runtime for me to be able to use them back again. So that was for the standard RHODS. And now I'm going to show you how Boston University used it. So this is a course. This is a standard computer science course, and this is the full textbook, okay, for this course. So all the content for the different lectures that this teacher was giving, okay. It's also fully open source in this case, which is interesting. But the thing is, that's the textbook. Okay. From a textbook, usually you have also something that goes along, which is the lecture notes. Okay, so that's the content that normally you would distribute and let people use to do their own experiments. Okay, if I go to the assembly programming introduction, you can see that okay, there are some commands that are passed, and later on in the course, they are fully compiling an application from scratch. So that's what they are learning in their computer science course. But that's where it gets difficult in a standard environment, because all of those lecture notes and exercises are based on the fact that people have access to an environment where they are able to run that. Okay, and as this is a course based on Linux, okay, that kind of disqualifies from the start Windows users unless they open some embedded Linux version or a Linux VM inside their environment. If they are using macOS, the syntax will be a little bit different and the rest. So you see all the pain points that Frank talked at the beginning of this presentation on how to ensure that we have common ground for all our students and the rest. This is what RHODS solves. RHODS for Education. Here, in this case, I am, in fact, in the notebook version of the lecture notes. Okay, so here, if I go to SLS Part 1, Unix Introduction, okay, you will see that, in fact, it's the same content that I have here. But at the same time, because this is a notebook, I will be able to run commands. I will be able to test what's written inside this notebook as examples. Okay, let me find one like this. You know, they have some, of course, some things that you can run. And here I could clear all the outputs just to rerun something. Okay, those are the commands that you want to run. Oh, okay, perfect. I can run this command and see exactly what's going on. So maybe I could also slightly modify this command and make some tests and whatever. You bring interaction in an environment where you are sure that each and every people is able to run this. Okay, then again, that's the common ground. That's the that's the only way to have your people totally autonomous in doing those things, instead of complaining that they cannot run this or that. Okay, if I open some other things, so again, they come from the lecture notes here. There is the terminal, so it's a full content of the course of the terminal. I wanted to show you this one because you can also embed videos directly inside your environment. So that's also a nice way to interact. And the last notebook I will show you, it comes from this part of the lectures on assembly programming. Okay, that's lecture number 7. And you can see that in this lecture notes, they have some commands that they can run. And that's why here on the right side, I have a terminal that is already open, because then as a student, I can do this directly inside my environment and see what's happening. And can go a little bit further. Okay, what do I have instead of ls that is available? Okay, I have all those things that I can try this command down. So as you see, again, I'm not limited to just watching, just reading the lecture notes. I can totally reproduce and make them running inside my environment. Okay. If you look at the lecture notes themselves, okay, most of the commands, they are already run. Okay, so that's interesting. But from a teaching or from a learning point of view, it's way better to have people directly running those commands for themselves. So here, instead of reading the results of this command, maybe they will want to run that directly inside their environment and see doing, oh, okay, yes, that's, I'm looking at the LS file from a binary point of view to see what's at the beginning of the content of this file. Okay, they can experiment for themselves. So that's the idea here. It's to go from a mostly fixed environment, fixed textbooks, fixed lecture notes, and then hope that people will be able to reproduce what's in the course. It's going from there to an environment where you are sure as a teacher that people will be able to follow along during the course, do their own experimentation, and maybe even do the exercises or do the tests and then submit the tests, because that's also something you can do. You can have maybe like all your students create a Git repo for their assigned work, and then they can work in this environment. They have access to everything that is needed to be able to do this specific assignment, and then they just commit to the Git repo, and the teacher can grade directly from this result. So that's also an interesting way to look at that. And that's all I had in terms of demo, and we can come back to that depending on the questions that you may have.
All right. Well, thank you, Guillaume. Yes, thank you very much. Great, great demonstration. Really appreciate that with you sharing. And so let's move on to next steps here. So we've got some additional resources for you. We are going to be sharing this deck with you. So some links for you to have available, and call to action. All right, so let's talk about this. So the next step would be for you to get hands-on with RHODS directly. And most of our partners have access, if not all, to our RHPDS, Red Hat Product Demo System. Please reach out to your channel team or your channel solutions architect if you have any questions. RHODS is available in RHPDS and available for you to demo, to get your hands on and work with it. And then prepare to give a client demo. So try it out, and you know, with a friendly walkthrough, and then look to take it to a client. And we're happy to have a session with you on approach strategies with clients, with Red Hat reps, if you're interested in having them join, or with our channel team. Let us know. We're happy to work with you on that. And then share the Boston University case study. Clearly, that's a nice success and a big, you know, credible university that's using this very well. Understand, you know, what they're doing today, what your educational client is currently managing their computational educational environment, and then feel free to reach out to us with any questions. You know, we're here to support you, especially early on as we take this to market. So now let's move to a more general Q&A. I'm going to change the format here so that we have a broader screen of folks, and chat about some of the questions that have come in. And by the way, great timing, everybody, on the presentation and demo. We're doing very good on time. So one of the questions was, as a partner, since this is a cloud service, at least initially, how do we make money? How do we get compensated for selling RHODS as a cloud service? And so let me just throw that out to Will McGrath. Do you want to answer that?
Sure. Yeah, definitely. So I think part of it will be just the consulting services that you have to kind of wrap around, you know, implementation. A lot of people will actually do a lot of the training and model development in the cloud and then deploy it on-prem. So for your commercial customers as well, that's likely. And a lot of the universities as well will kind of could use this service as kind of building the models and using it for classwork. but then also being able to complement that with some on-prem capabilities as well. So I think that provides a good opportunity for you to kind of not only sell the service directly, again, compensated for selling OpenShift managed cloud services, as well as the AWS underlying infrastructure and OpenShift data science, but then also the consulting services that wrap around it.
And I would really underscore that too, is the fact that most of the compute resources that you're going to need is to build the model. Once the model is built, that can be deployed on anything, right? So
Yes.
that is where I think that the real potential of leveling the playing field, because MIT is going to have, radically different resources than your local community college. So I think
that's a great point. And there is this makes a terrific environment to like build and then tear down, right? Like some of these hackathons even, right? Or a special project at a university or even general, right? Bring it up, tear it down, get your results, whatever's needed. So that's a great point, Frank. All right, follow-on question in terms of pricing and packaging for universities. How does that work? Will, you want to share there?
Sure, I'll take a first stab at it. Yeah, so basically it's priced right now as a yearly price model. So I think it's priced per virtual CPU. I think it's around $164 for a virtual CPU. We are adding a consumption-based model, which will be kind of an hourly-based pricing. That'll be introduced probably in Q4 timeframe. But we have a number of different resources that we can kind of work with you on. There's a cost estimator calculator that we can kind of use to help estimate what the AWS costs and the cloud costs will be, along with OpenShift data science. So that's currently how it's priced today.
Great to hear. And then CPU based, virtual CPU based, and then move into a consumption model going forward. So lots of flexibility. So one of the first steps would be, for a university, an educational, institution to move forward is they would want to touch and feel and, after the demo, set up some sort of a sandbox to see if it meets their needs, what, customization is needed, what services, consulting from the partner and so forth. Can one of you talk to how that happens?
I'll start, and then Guillaume, if you want to jump in, or Frank, you want to jump in. So I think for the customers, I think there's a free developer sandbox that's available on the developers portal at Red Hat. So it doesn't have any cost in terms of the AWS infrastructure or anything like that. So customers can play with it. There's a lot of good little exercises that some of our data scientists have created, of like how to get started with Jupyter, how to import data from S3, how to actually deploy models using source to image into OpenShift environments. So you can take those models and deploy it into intelligent applications. So all those little training tutorials are available on the developers portal. So that might be a good place for people to get short-term access to it. And then we have a number of different, I guess you can call POC environments that we can also provide, at free cost for people that want to play with this environment on a more, business-oriented, a long-term engagement, if they want like a 3-month type of a POC. So those are two examples, places of how to get your hands on it and get started.
Anybody else want to weigh in?
I guess that Will covered it pretty thoroughly. That's exactly the path to follow. Definitely first the sandbox, because that gives you almost instant access to RHODS environment where you can experiment, you can play, and you have access for quite a long time. So then you will have to discuss with Red Hat for other options if you want to go further with the POCs. And here, there are many different options depending on where you are right now, which type of cloud services you are already consuming or not, if you already have an OpenShift cluster somewhere in the cloud. So many different options. That's where it needs some discussion with our team to see what will be the most beneficial for you to test.
Absolutely. And remember, the implementation time for Boston University was weeks, not months, certainly not years. This can impact your bottom line this year, right? This is the path to getting this deployed and servicing your customers and making revenue from this is very short, much shorter than I think that most people are used to.
Great point. You know, there was another point that I learned as we're preparing for this, that it really democratizes this environment for universities, right? Before, small, even mid-sized universities were not able to put together these environments. Only the bigs, right? They had the resources, the knowledge to be able to do this, integrate, manage, and so forth. And so having this environment now levels that playing field. So because of that easy button that we talked about earlier. All right, hey, last call for questions from our attendees. And while we're just giving one, last chance, anything else from the panel here? Any final thoughts before we wrap up? All right.
Maybe yes. We can, one small thing. Here we are focusing maybe on higher ed or specific educational institutions, but the same principle will apply to any learning organizations. So it can be, consulting services, which are providing courses on various subjects. So even courses for a large company. Let's say you are a large bank or financial institution and you want to train your people on data analysis and the rest. This is also a platform that would perfectly fit for that. So here from all the demos and everything that Frank explained, of course, it's focused on educational institutions, but you can also think about this in a broader way on anything where there is learning and teaching involved. It will perfectly fit the needs.
And another idea would be to pitch to your customers if they could have a hackathon, right? Because this is a great idea for a lot of companies may want to do this to encourage new ideas, new innovations, that sort of thing. And because of the low barriers to entry, it'd be very easy for a company to have a hackathon.
Great points. Hey, and along those lines, just so that everybody knows, we are going to return with a more general session in August on RHODS overall, not focused on education. So for those individuals, stay tuned for that. And with that, let's move to wrap up. So thank you for joining. Special thank you, Guillaume, Frank, Will, for joining and helping set this up. So for everyone, hope you're enjoying your summer and stay cool. We're going to get the deck and the link out to you shortly. And thanks again. We'll talk with you again soon. Bye-bye.